Hi, thanks for watching. You'll be more familiar with Excel, how to use some basic troubleshooting through experience, tricks for discovering and solving common errors, and what you might call workarounds. So I've been working in Excel for about 20 years. I've worked as a financial analyst and stocks and bonds trading. So I use Excel for various reasons, including looking at loads of data and what amounts to long drawn out spreadsheets with some calculations embedded in it. Lately I've been using Power Pivot and Power BI to analyze larger amounts of data. So I'll look at graphs and tables instead of numbers because it helps me spot things like, things that look like outliers and so on. I've worked for the government as a contractor and I've helped distinguish visualizations and do budget and cost analysis. I have some development skills in Python as well as SQL. I've developed full-scale, full-stack websites using Linux, Apache, MySQL, PHP. So I've learned a little object-oriented programming, layouts, and so on. This is for the benefit of those that would like to study those things in related videos. But today, let's get right to the chase and discuss what we're looking at. We're looking at the following topics: how to convert error messages that occur sometimes in tables when you're dividing numbers that yield that message, and what the workaround is. I use something called the if error. In other words, if I'm dividing two cells and one happens to have empty data and I get an ugly set of errors, well, that can be solved by, instead of just using the formula, say equals if error, then you put your formula. So if there's an error, the way the spreadsheet works is it's going to run what's in the parentheses first, and then if there's an error, it's going to render a message. If you don't want an ugly message, I usually just put a 0, so that if in fact I'm looking at it, it just doesn't look terrible, does it? Then I can footnote it, add notes to the cell, and move along my way. This is a spreadsheet which shows data from a stock market watch list. On the far left, I've got a column that shows the name of the watch list. Here it's called the Merrill Edge Companion. The view is called Basic, and this is pulled from TD Ameritrade, where one can set up a watch list. In this case, I was looking at a few stocks indicated there: CBLI, AOSL, JBHT, which is JB Hunt, PHUN, which is kind of like a penny stock. Now, through TD Ameritrade, I was able to export information from this watch list at any given time, and it exported it as tab delimited format. So I can use tab delimited format. After it's downloaded, I will click on it and open it in Excel. Usually I'll move it from my downloads over to a document called, exports, and then save it as a Excel file when I get the chance. But this is what the data came in looking like. It's not particularly complicated. Column for quantity, market value, because I don't really own them right at the moment. These are just what I'm looking at to do some, data mining. The opening indicates what the price was at the beginning of the day, which is 9:30. The price, which is what it was when I downloaded this data. We can eventually add a date stamp, and we can go over that later. But let's look at the next column, which is the change and change percents. So at the price, the way TD Ameritrade describes changes, it's the change from the previous day closing, and markets are open till 4:30 generally. Sometimes there's after hours trading till 8:30, so it's just up to you. Anyway, that might not be relevant at this point in time, but what I am really looking at ultimately is how to rank and sort these. So for instance, if I wanted to look at this, in this particular case by volume, I would look at the volume column where I see 418,000, followed by 1 million, followed by 508,000. So if I wanted to add all that up, it would be complicated because unfortunately these numbers aren't going to be interpreted very easily, and they were exported as tab delimited text. As you know, when you export things over the internet, they're only traveling there as strings. So if you're going to be messing around with them in Excel, you got to make sure that they're formatted correctly. So the real question here is, how do I remove that K and translate it into the actual number that it represents? In this case, we're going to discuss fundamentally how this process looks like from a database perspective or a programming perspective, and then from layman's terms. So once this data was exported, I was able to do a little bit of finessing. What I did is I looked at what are my options for analysis, and generally speaking, certainly I can render some data analysis by maybe capturing what is the, what is the 90th percentile of of a stock's value. So in this case, under XLV, which was listed twice there, I would look at the price at $124. I might want to say, what is the price? What is 10% of that price? And say if the stock comes down to that particular price, send me a push notification so I can look at it further. I'm looking to buy stocks when they're cheaper, generally as cheap as possible. And as you know, stocks go through gyrations. As you learn about stocks and bonds, you'll learn that at any point during the day, a candlestick will form, and a candlestick really indicates the activity, the price, and the price over the course of a given time period. A candlestick will show the high and low for the day, and what amounts to wicks. Wicks are very small volume price movements, and we'll go over that in another video as well. But for today, if I am trying to calculate what's 90% of a specific value, I'd have to create a new row and do some manipulation on it. However, if I put this information into a table first and I write the calculation in the top row of a specific column, the entire column is going to be filled without doing a lot of that extra manipulation that I was explaining earlier is involved in Excel. So what I learned is how to always consider data in tabular format, or what's called tables. The other benefit is if I don't really have a rhyme or reason to the symbols, I can sort them in ascending order and descending order. If I want to sort them by price value, for instance, if I'm only interested in stocks over $100, I could sort it out by high to low, and all of a sudden I can just focus on those. Conversely, if I'm looking at the cheaper penny stocks for whatever reason, I can sort from low to high. And then some people also like to look at stocks and bonds as they change, in terms of value over a period, and percentage wise here I might want to sort like what was the biggest move. Generally speaking, strategies involving biggest move or small moves are important to consider. Like I like to look at cherry picking stocks that have gone real high and then noticing there's probably going to be some price action, and then maybe shorting the stock for $1 or $2 and collecting some premium. So those are sort functions that are not really easy to do without putting them into a table. Okay. The way to put things into a table is you generally speaking want to look at the top of the column, make sure they're all in the same row, and make sure they're named. If they're not named, what's going to happen is you're going to have like a bunch of column IDs up there that you didn't get to create, and for later purposes involving maybe sharing data, no one's going to understand it. So you want to document things as best you can. This is a view of that table we saw in the previous slide, except it's formatted. You'll notice the top row is in dark blue, and its cell context is written in white text there that you can read easily: symbol, quantity, market value. Again, in the box there, I'm indicating there is an issue here with the final column because I'm only able to see numbers as it pertains to alphanumeric characters. I can't really add and subtract it. If I wanted to take 90% of 9.7 million, how am I going to do that? It doesn't understand 9.17m because it's looking at it as a string character, what they call alphanumeric. So we were discussing ways to look at this in problem solving. So fundamentally, programmers will tell you, we learn a few basic things about about inputs. So in general, when I'm coding something, I'm taking inputs from a user. For instance, when I log into a normal web page or even to my email address, email web page, I have to send them my username and password. They're taking that over the internet. They're matching it into a database to pull back my credentials. If it matches, they show me a page. Then if I want to place if I want to place some kind of order or want to chat with somebody, I'm typing stuff in. Usually over the internet, things are stored as string. And if I want to actually do some work on that string, I can, download it into into my own programming environment, what's called an integrated data environment, and I can look at the data there, or store it in a database. Usually both. Usually I'll throw it into a database and then I'll look at it and analyze. In the case of this spreadsheet, I'm going to be looking at storing this data in a database and then working on it. So I might pull the values for the volume column, and I might put it into its own Excel file. Isolating that is important because it helps us think about what's going on. Now, in the context of programmers, most of us that use Python understand like a string or an alphanumeric character is stored by digit. So 9.71 million is shown in the XLV row there, is actually stored as what amounts to an array of individual items, the number 9, the number 7, period, the 1, and the M. So from a developer's perspective, my first step would be like, okay, how do I just examine the items in that particular cell, excluding the M? So I would think to myself, okay, well, there's a very simple pop method, a method that says, let's just look at the every character in a string except for the last one and pop that last one. Okay, problem solved. I've got 9.71, and if I multiply 9.71 by those 6 zeros, I'm multiplying it by a million. So lo and behold, I have a new column that reads 9.71 million. Now, in the case where I'm popping items with the K, I'll be multiplying by 1,000, not by a million. So I'll have 89.1 thousand and not 89 million. Again, that's using a developer mindset. And if you're watching this video and you have an interest in system engineering, you do really need to learn what does it mean to develop code or develop a solution. You need to know how it was engineered and then re-engineer it. In other words, 9.71 million isn't a number here, it is a varchar. It's something that contains strings and numbers. So it's accepting the number, it's reading a number, but it's also taking the variable M in there, or the letter M, not a variable, it's a separate thing. But in this case, a developer would say the simple solution, okay, is to lop that off, multiply by a million, and I've got a new column. However, I'm working in Excel. I don't in this particular video want to go into solving this using Python, because technically Excel has its own framework to do things that are similar to that. There's another term in developing aside from the pop methodology, which is called split. So split goes hand in hand with what amounts to the developer tool or developer idea of parsing. And what parsing is looking at a data and perhaps inserting a carriage return so it's easily read on the internet or on a web page, or inserting a paragraph break. All these typesetting tools that you understand and take for granted when you read the newspaper, or if you've ever worked on a newspaper, you understand that typesetters have to put in these codes in the computer to render a new paragraph or to render boldface type. Microsoft Word is another example where instead of needing to learn all the code to do those things, it actually just does mouse click points to create a new paragraph. You might even go into sizing the picas and font sizes and stuff in its own interface, but that's interjecting some sort of type code into the binary, the stuff you don't see under the hood. The reason I'm mentioning that is because another interesting solution is what if we were able to look at 9.71 million and look at it as just a 9 in column number 1, just a 7 in column number 2, just a 1 in column number 3, and then just an M in column number 4. So that value would be spread across 4 columns in a spreadsheet. So intuitively, Microsoft Windows, the .NET, the C# framework, the VB, the .NET, all the stuff that goes into Excel behind the hood to create this little spreadsheet is a development-based background. So there are a lot of programming languages out there, and they have similar syntax. So we know not only can I just pop and lump off that M, but I could maybe split that, split that entire string into separate columns. Why is that important? Because Excel actually knows that this problem happens from time to time, and it's going to include a shortcut. By clicking on the data section there on your Excel spreadsheet, you're going to see a little symbol there, which is called column to text. When you click on column to text, you'll notice it's going to say, in this particular column, I'm able to actually divide it, just as we had spoken previously. So let's take a look at that in greater detail. And remember, there's an issue identified here as I've got data. I can't do anything with it because I can't multiply it by 10%. I can't add it, and I can't sort it. All right, thanks for watching. So we're taking a good look now at this spreadsheet up close and personal. I added this little arrow sign to indicate if I click on the little triangle button next to the volume column header, I'm given the choice to select sort in ascending order, sort in descending order, which is what I did. And unfortunately, as you can see, it didn't do a really stellar job of doing anything. So with that in mind, I went to the Data tab in Excel, went to Data Tools, and you can see it in the upper right-hand corner that there's a column called Text to Columns. Clicking on that produces this dialog box, and it's telling me, oh, I've noticed that in this column, you've got all these cells. Now, are these cells in and of themselves in some way, organized in a specific way? And the way Excel would organize something is delimited or fixed with. In this case, you're going to say it is delimited because effectively it's a table that is delimited by column. Things in each column have unique features. They're all volume or they're all price. So the way this computer stores things in binary instead of visuals, it's going to have this tab that separates the values in the volume column from all the others. So there's a tab between those things. So we know as programmers that I'm going to leave this checked as delimited. So it understands that in this case, whenever it's sorting through a column, what's separating each row is this, is this tab value effectively. Anyway, let's move on to the next one. So we've just clicked on the next button, and this time it's just double checking that you don't need to sort this any further. The delimiter we've already mentioned was exported from TD Ameritrade as tab delimited text. So since we only have one column selected, we're looking at a column in the spreadsheet, but by default it's going to pop up what it was as a whole. This entire worksheet, even before it was converted into a table, was tab delimited. So instead of having columns, it had tabs in its generic transport over the internet. And over the internet, things are transported as string with, like we had said before, a carriage return, some kind of symbol to express when it reaches its destination. Insert a carriage return after a sentence or a period, or a paragraph. So what I'm showing here is that there's the option to select other, and in that other I inserted the letter capital M. So what happens when I insert that capital M is I'm telling it, well, in this case I'm delimiting, and I'm delimiting by tab as well as M. So whenever there's a new row, okay, there's a new entry. But let's add a way to delimit this text further, and that is M, which is to say, let's say the M on its own is an entity, and everything before the M is its entity. Everything after the M is its own entity. So looking at the first two rows, we don't have two cells anymore. We have four entities. The numeric value, the M, the next numerical value, and the next M. However, because I'm also saying it's a delimiter, it means it's not actually containing data that I'm interested in. It's just containing a separation, like a carriage. It's actually just doing a separator. It's like a carriage return or a new paragraph. So when I hit next, you're going to see that instead of seeing 9.71 million, I'm going to see 9.71 because it's interpreting the M as a delimiter. So all I wanted to add in this slide, as you can see, the M was removed. You can leave the tab there marked, or you can check it, uncheck it like I did. So now you can see the M was removed. It doesn't solve the problem that 9.71 is not the number I want. I want the number 9.71 million. Ultimately, I can create a table reference and say multiply all those things in the column by 1,000,000, and all those that don't have, you know, an abbreviation or a letter after it are going to get multiplied by 1,000,000. But let's get to that when we get to that. Right now, I just wanted to confirm that you understood in the previous slide we had the issue of having an M in front of things, and that we removed it because it was considered a delimiter, and a delimiter doesn't contain values we're interested in. It just gives the command to move to a new line. So it interpreted the M as a delimiter. In programming, specifically Python, which is a very simple to understand and learn language, it stores data instead of in an Excel spreadsheet in what amounts to like Word format. What I would say Microsoft Word format, I'd say like sentence format. So I can insert a number, and instead of inserting it as just a bunch of numbers on a Word pad or a Word document, I insert it in brackets. When it's in brackets, it reads it as a number. When I insert it in braces, it reads it as one of many numbers, etc. So we're using these extra things in Python to look at numbers, and effectively it's used primarily for storing numbers and doing, you know, data science and so on it. So I'm interested in that. So one of the things that we talk about in Python is if I'm looking at a bunch of numbers separated by columns and I want to do some kind of computation on them, well, let's look at every number uniquely, and we'll again specify that comma was a delimiter, or more importantly, use a shortcut without even, you know, thinking about it the way Excel did in a very, very complex way. We'll just say, you know, if it's in a bracket and it's separated by a column, every value between the commas is considered its own value. And eventually, if I only wanted to look at every other value, I could insert a formula that says, please look at every other value. And the way it does that is by using what's called a step function. It looks at every value in a list, if you will, as being a member of a positional group or a positional array. So the first member is always, you know, belonging to an index value of 0 or 1. The second one is belonging to the index value of 1 or 2. R is a language similar to Python. It starts its index values at 1. Python starts it at 0. So if I'm looking at the first number in a series, I will say, please show me the first number, meaning show me positional value 0. If I want to see the high value, please show me the positional value at high, and it interprets, you know, it's automatically going to sort it for the high value. Okay, those are little things that I wanted to specify as being unique about data science in another language, which is harder to do in Excel. So once we clicked on Finish, that dialog box that was open in Excel when we were hitting the text to columns, we're looking again at our values at our Excel spreadsheet. So what I'm doing is I'm showing you a side-by-side comparison of what the data looks like in a table, which is what we had recently worked in, and, you know, just its own little you know, row by column formatting that Excel does, simply for comparison's sake and presentation value. Looking at it from left to right, I've got the high, the low, the volume, and I've added a column there called volume 2. I'd prefer to create a separate table, if I'm adding columns to a table because I want it in its original integrity. Eventually I only want to look at it in one specific way. So I cut and what I had to do was cut and paste the values from the first table. Cut and paste the values in the first table into a separate worksheet in the same workbook. Could have been in the same worksheet, but I pasted his values because I wanted to, I wanted to work with these numbers individually, not as members of a table. And I'll explain that to you later. But at the end of the day, we've added a new column there called volume 2. Volume 2 now is taking the the new formatted 9.71 column, which was 9.71 million, and it's multiplied it by the correct value to become the values we want to look at, which is 9.7 million. I added a column for later reference called what I would call kind of like this middleware value, because eventually if I wanted to work on it more, I would want to remember that this value either needs more formatting or it doesn't. So I created an if-then statement, a conditional statement that says, no, it doesn't need more formatting, or yes, it does need, okay, yes, it does need more formatting. And wherever there's an okay, you're seeing that there's a row there which has the K in it, which means I still need to work on it. Over there, over there in column, in the last column there, I've got another column there for volume. And that's simply a placeholder because I know I'm going to run another conditional test on this column, and instead of separating things by the M, I'm going to separate it by the K. So this is just a step forward in getting my stuff formatted correctly. Hey, let me ask you to smash the like button on this YouTube video and share it with your friends. There's a donate button there, so if you want to donate what amounts to a couple bucks, I'd appreciate it. Now, we talked about errors in formatting. Here's an opportunity to show what you can do to avoid errors. In that last column, in that last slide, we looked at the third or fourth column containing the 9.7 and the 9.7 million correctly formatted columns. So what I did is I took the column 9.71 and multiplied it by a million shown in the original workbook. But if I multiplied the values with K times a million, I was going to get this ugly error in that last column. To avoid it, I used what's called the if-error function. Functions are built-in calculations. Functions are just what amounts to computing code or routines that the computer will do if you give it a specific what amounts to a condition or a specific route. So ordinarily you type the equal sign in a number or formula into Excel. In this case I typed in the equals, but I said, look, if I get an error message here for whatever reason, don't show me an error message. In this case I said, show me the values in the column as they are. And the column contained volume 2. So the formula is going into the last column there on the right. It's saying equals, multiply that volume column by a million and put it in, and show it to me here in this column. And if there's an error, show me the value as it was originally in that volume 2, which shows the K. In this slide, I just wanted to reiterate or make sure you paid attention to that column saying no and okay. That was an intermediate column that I said, look, we've solved the problem of converting millions to millions. We've solved the problem of eliminating the error when I duplicated the column. Now I want to go and repeat the system that I did before. I'm going to split this value by K, get rid of the K, and multiply it by 1,000. But this is just a reminder. So in this very final presentation here, I'm just going to reiterate. We're going to look first at the table on the left over here, and what we see is we went and we removed the K from the numbers in this column. So what I had done is I created a conditional statement where if I needed to do some formatting on it, I use the yes and no's here. If if this is no, I was just going to type a 0 in this column. If it's okay, I was going to retype the number. When I retyped the number, I knew then that that was the one I was going to sort, so I didn't have to sort through too many things. It saves bandwidth. So I went back to the data, I selected delimited, and I said K, so all of a sudden the K was removed. So we're looking at K's. Then in this column here, I'm showing you the end result. I multiplied it by 1,000 instead of 1,000,000, so everything is good. Over here, please take a look that I included, the column headers, and I sorted it from high to low. So you're going to see the numbers are now sorted. That's the purpose of all the stuff that we went through. I hope you enjoyed the video. I know it went a little longer than I would like, but it really does drill through the 3 basic points we discussed at the beginning. And those points again are, let's go over them one at a time. Okay, so first we wanted to get rid of error messages. We're using the formula or function if error. Okay, so you're typing in equals if error, parentheses, and then you're typing in your formula. You're following the formula in parentheses, end parentheses with a comma, and whatever you want to replace the error message with. In this case, I used 0. We inserted a table to look at data that was then sortable from descending into ascending order. And we looked at the feature of what amounts to removing the last digit in a string that comes across as a non-integer value or a non-numeric value. We did that by thinking of it in programming terms as not just a number, but as a list of letters or numbers from left to right with an index value so that we could lop off the last one. More importantly, we were able to use a built-in feature in Excel that let you not just simply create a formula, but just interpret the letter as a delimiter, as a thing to look at, a separator. So by doing that, I immediately stopped considering it as a value at all and was able to turn everything into a number and then multiply it by the corresponding value for K and M. I hope you enjoyed this video. I'm going to be making a video on how to solve this problem using Python, and I hope you like it. It's going to be an introduction to programming using the concepts of Excel. If you sat through this video and found it interesting, smash the like, send me a friendly contribution of no more than $5. And I do have student loans to pay, and I appreciate it. I think this was informative. It gave you an introduction to data types in Python, data types in Excel, and data types in SQL. We covered tables, which are able to sort things, and we covered some error formats. And I will review this video, and I will post any spreadsheets that I used. I will give you access to my Azure DevOps account too, or my what's called a GitHub repository, and that GitHub repository, which is much like an Azure repo, will give you access to the code. So I hope you liked it. Send me your email and phone number if you have any questions or want to sign up for more courses. Thank you. Bye.